Good afternoon. Thank you for taking the time to meet with us. We are the Data-Driven Racing Team, also known as Team 7. First and foremost, I'll introduce our team. AJ Jaffrey, the weatherman, our expert in web scraping and Python modeling from Stamford, Connecticut. Next, Joey Sericola, the guy who puts the power in Power BI, our team lead and also app builder from Redmond, Washington. Next, we have Ryan Devlin, the Steven Spielberg of presentations and our modeler extraordinaire from Palo Alto. Where else? Next, Sergio Muir, yours truly, Mr. Interview and general researcher from Springfield, Illinois. And finally, Tiffany Blakeney, the maven of modeling, our SAS Enterprise Miner expert from Palo Alto, California. Let's jump right into the project. Let's kick off with a bit of housekeeping by walking through the agenda for our time together. Speaking of that, we'll spend 50 minutes explaining the project. Given the findings and the positive revenue implications of our recommendations, I am sure that it will be worth the additional 5 minutes of your time. We'll begin with a summary of the problem that has been tackled, followed by our objective. From there, we'll discuss our data. This will include data sources, initial thoughts on the data, exploratory data analysis, and then data cleaning and transformations. Next, we'll explain our approach to modeling and analysis. This will include data visualization. Oh yes, we will do a demo of our new app, but I'm getting way ahead of myself. We will discuss modeling with SAS and R and our analysis and discoveries. From there, we'll move into the real reason that we're here, the recommendations. We will show how our strategic recommendations tie to the additional revenue for our organization, Haas Formula One Racing. We will then conclude with next steps and closing comments. Like many sports, Formula One racing teams are split across a great divide of haves and have-nots. The biggest, oldest, most successful teams have annual revenue at 10 times the level of the smaller, newer competitors. For example, the Ferrari and Mercedes teams earned 10 times the revenue of Haas in 2017. To compete, smaller teams must focus their limited resources on those factors that have the greatest impact on increasing Formula One points and thus revenue. I must pause there. Note that I did not say greatest impact on winning. I said points and thus revenue. We'll come back to that distinction. During our project, we interviewed Daniel Knost, Director of Vehicle Dynamics at Haas Racing. He highlighted for us the importance of analytics in racing. He said, "Racing is such an expensive and complicated endeavor that I think if someone were to really make a breakthrough in the analytics as you are attempting to do, it could form a real competitive advantage." The competitive challenges facing Haas remind us of the Oakland A's in Moneyball. Faced with limited resources and mediocre results, the A's used analytics to find new ways to compete against major league titans like the New York Yankees and the Boston Red Sox. The A's learned that getting on base could be more important than hitting home runs. We believe the concepts from Moneyball can be applied to Formula One racing. Of course, we don't believe that any one of us is as good looking as Brad Pitt, but back to our narrative. Through analytics, we will show several strategies that will earn Formula One points for Haas. This will translate directly into revenue dollars, given Formula One revenue sharing rules. Shifting our focus to maximizing points rather than simply attempting to win each race will maximize revenue. Yes, even small incremental improvements in points will have a material impact on revenue from Formula One. This will also have positive impact on our sponsorships and driver recruiting. To put our problem succinctly, given the wide disparity of resources across Formula One racing teams, Haas must find ways to compete more efficiently and increase revenue. There is much talk about the use of analytics in Formula One racing. Each race, each car generates a terabyte of data. During each race, this data is bounced back to England for immediate analysis, followed by adjustments to the car. Much of this data is used to improve car performance through aerodynamics, engine output, etc. Real-time car performance is not our area of focus. We'll leave that to the experts. Conversely, it is easy to derive non-car performance strategies from analytics that are just simply not practical strategies. For example, according to conventional wisdom, according to our analysis, according to our subject matter expert, the most important factor in winning races is to have the best driver. In a perfect world, Haas would simply hire Lewis Hamilton, hire him away from Mercedes. Lewis is the Michael Jordan of Formula One racing. Yet given contracts, given Lewis's compensation, hiring Lewis Hamilton is not feasible for Haas. Our objective is to provide affordable, feasible strategies that will result in higher Formula One points and thus revenue. We think of it as the Oakland A's hitting more singles and thus winning more games. Let's shift gears. Does anyone win when Russia meddles? Some say nient, but we say yes. Of course, I'm not talking about politics, I'm talking about Formula One. Putin's rumored meddling in Formula One just might create an opportunity for Haas, resulting in a win for Haas or at least more Formula One points. Buckle up and we'll show you why and how this ties to our work with the data. I will now turn it over to my teammate AJ for a discussion of data.
Thank you, Sergio, for that lovely introduction. So now we're going to go over some brief background on the data used for this project. Our primary data source was obtained from Kaggle.com, specifically their F1 race dataset. In full disclosure, this Kaggle data was originally sourced from an enthusiast website called ergas.com, which hosts an API or an application programming interface that provides a historical record of motor racing data. This data set contained data from 1950 all the way through the 2017 season and consists of relational tables describing race results, constructors and teams, race drivers, circuits, lap times, pit stops, and more. The lowest level of detail available was the lap level information, which consisted of over 450,000 observations over the 67-year period. Now, the race results data included whether a driver was able to finish a race, how many points were earned, and whether they were flagged with any penalties. If a driver was not able to finish a race, the data set contains a categorical value, status ID, which specifies the reason for an unfinished race. This can be due to several reasons ranging from an accident to engine or some other mechanical failure. In addition, the dataset also contains a record of all the qualifying results for each Formula One race. The better the qualifying results for a team, the better the grid position in the official race. Lastly, we have several pieces of metadata relating to the racing circuits, drivers, and the teams. We will revisit this briefly, as some of this metadata came in very handy during our project. So in terms of our initial thoughts on the data, we experienced considerable challenges in making sense of this data set initially. So we decided it would be best if we found some subject matter experts in Formula One racing for consultation. Our teammate, Sergio, was fortunate enough to secure 2 initial interviews, one with Daniel Nost, the Director of Vehicle Dynamics at Haas, and another with data scientist and Kaggler, Jonathan Bouchette, who had some previous hands-on experience with this exact data set. There were a few key takeaways from those interviews. First, the point scoring system has changed many times throughout Formula One history, most recently in 2010. We should therefore limit our dataset to 2010 and onwards. Secondly, Daniel highlighted that there were actually many different races within a race that may not seem apparent to outsiders. Although every driver would like to win, some are simply racing to finish. Others are racing to finish in a certain place or better. Third, it seems that difficulty can vary widely based upon circuit location and road conditions. And fourth, weather was an important factor that could alter the strategy and outcome of each race. So now, with those interview takeaways in mind, we realized that our primary data source, as it stood, was insufficient in a key area. We decided it would be best to enrich our data set with weather information unique to each race. Fortunately, as the Kaggle data included a separate table with metadata relating to the race circuits, we were able to leverage the latitude and longitude GPS coordinates along with the date of a race to enhance our primary data source with 30 additional weather-related attributes, including temperature, wind speed, precipitation, air pressure, a rain flag, and several other useful variables for our modeling. This weather data was sourced from weatherunderground.com, where we utilized their developer API to scrape historical weather information programmatically using Python. Now, I want to quickly highlight some points from an exploratory data analysis of our enriched dataset. This EDA leveraged Power BI, SAS Enterprise Miner, and R. Our first observation in our visualizations of the data showed a strong correlation between driver and points earned. This fits with the hype that we hear as spectators of the sport, and far more importantly, it fits with the comments by one of our subject matter experts, Daniel Nost of Haas Racing. Next, a world map visualization of the race locations highlights the global nature of the sport, coupled with the wide range of environmental conditions faced by the race teams. Interestingly, there was also a clear difference in race lap times on the same circuit as different weather events impacted road conditions, which also fits with comments by the SMEs. Finally, we notice a number of missing values, a need for a data transformation, and standardization of measures of time. As a result of what we discovered from our exploratory data analysis, we took a number of actions to cleanse and transform our data to a format that will be useful in our modeling. Given that the data was split across 13 different tables, we examined the relational tables for common keys, which allowed us to combine the data sets into one master file. Creating one master file was important because it allowed us to facilitate modeling across all available factors. The initial resulting file is still contained over 450,000 rows because it was at the lap level. We decided to transform our data further, though, so that each observation was equivalent to one unique driver at each race. This required us to pivot the data to show each lap as a separate column rather than a separate row. This decreased the size of our data set substantially, while also making it more useful for our modeling purposes. After reviewing the data and limiting our scope to 2010 to the present, we also narrowed down our dataset to the most relevant information by removing extraneous ID and status fields. The final transformed dataset consisted of a little over 3,300 observations across 153 variables, which includes the weather data. Next, we utilized SAS Enterprise Miner for imputation of missing data, which we evaluated on a case-by-case basis. As it turns out, many of the variables with missing attributes, like lap times, are actually null for a very good reason. It's simply due to many Formula One drivers not being fortunate enough to finish a race, due to various reasons which, as mentioned previously, are also captured elsewhere in our dataset. Finally, the last action we took was to standardize the various measures of time in our dataset to milliseconds. And with that, I will now hand it over to Joey.
My name is Joey Siricola, and I'm going to talk to you about data visualization. Data visualization is essentially the ability to visually tell stories with data. The goal of data visualization is to be able to communicate information clearly and efficiently via statistical graphics, plots, and information graphics. Effective data visualization can help users understand their data without much additional explanation. When it's done well, data visualization can simplify complex data to make it more accessible, understandable, and usable. In this way, it can be both an art and a science, and as such, proper tools are required in order to help analysts provide management and businesses with quality data visualizations. The tool that we used in our project for data visualization is Microsoft's Power BI. Power BI is a suite of business analytics tools that enable users to analyze data and share insights. In our project, we used Power BI's built-in importing feature to import our data that we had manipulated previously, do some further manipulation upon that data, and create some pretty powerful dashboards and reports that we were able to publish to the web and Microsoft Teams. With this ability, we were able to create mobile access as well as mobile apps that our executives and business analysts can use when on the go. We'll be demoing these features a little bit later in the presentation. As I mentioned, we first imported our data into Power BI. From there, we created some reports to help us to better understand the data underneath. What this helped us to do is to get better insights into what was happening with the data, as well as some insights into Formula One in general. Only a couple members of our team had much knowledge of Formula One racing, one in particular. As such, it was very helpful for us to be able to look at the data visually via charts and graphs and to understand what was happening. This particular chart shows the historical excellence of some of the top teams, and it helped to illustrate to us the uphill climb that Haas Racing has and illustrate the fact that they have to be extremely strategic if they want to climb up in these standings. The next visualization that we created was one with regards to the race venues themselves. What we wanted to see was historical data for each of the races, and what immediately stood out to us was the increase in race speed in terms of the fastest lap for each of the races over the years, as you can see in the graph in the top left. It was also interesting to see in terms of the number of races mapped out on the globe, as you can see in the far right. In addition, one of the key insights that we were able to pull out of this particular report was that the fastest lap in any race is typically the last lap. While this may seem logical and common sense, it's just great to have the ability to back that hypothesis up with real data. The next visualization we created was one surrounding the constructors or teams as a dashboard. Notice on the left-hand side we have slicers, which gives us the ability to slice and drill, as well as the fact if we click on any of the bars in the charts along the top or even in the rows on the bottom, all the rest of the charts and reports filter based on that, which is kind of a neat way to slice and dice the data to get key insights. One of the callouts we want to make here is again back to the excellence of the top teams. You'll notice in the pie chart on the right hand side, you're able to see that Mercedes-Benz and Ferrari have the key portions of that pie chart. This again shows the uphill climb that Haas has and the fact they've only been around for 2 seasons. Another visualization we created was one surrounding a driver's dashboard. Again, we have on the left-hand side slicers and filters to be able to slice and dice our data. Here we're able to see that in addition to top teams having some historical excellence, some of the top drivers as well have historical excellence. This initially put us under the hypothesis regarding the fact that the driver is truly important and a key element in a winning team strategy. Another key call out that we wanted to point out here that we found by slicing and dicing our data is that Haas did have, even though they've only been around for 2 seasons, they've already had turnover with their drivers where they've had one driver, the same driver over 2 years, they switched their second driver in the second season. In addition, we were able to notice as we looked through the historical data that their drivers came from other teams previously, and in those other teams, they had greater success than they'd had when they had come to Haas. This kind of called out to us the fact that perhaps they're dealing with inferior equipment as they move to Haas from their prior teams. Now we're going to switch over to a live demo of both our online dashboard as well as our mobile application. Here we are in our online dashboard. As you can see, we've pinned some interesting information and visualizations to the dashboard for our analysts and management to see. If you hover over, you'll be able to see some key information based on the data that's on the screen. You could also click in anywhere and it'll take you to further details about these key pieces. So The top left or the top of the screen is the circuit information and venue. The left-hand side is constructor information, and the right-hand side is driver information. As we click in, this is the same visualization of the screenshot that you had seen earlier. If we pan our mouse over, you'll see the lap times change year over year. If we go over here to the map and we hover, you can see information about the points on the map. If we click in, it actually filters the rest of the information on the screen, which is pretty interesting. If we click again, we can see here's the Canadian Grand Prix, for example. You can see year over year information all at the bottom. You can slice and dice on the left-hand side. Again, this is for constructors. If we go to the next tab, this is our driver dashboard. And again, you can do the same sort of slicing and dicing on the left-hand side. All the historical data is in the bottom. And if you click anywhere along here, it'll filter everywhere that you see. So for example, if we click on Hamilton, it'll filter down and you'll be able to see everywhere. Here's his slice of the pie, all of his points and wins information and finishes throughout the years. If we go back a step to the constructors, similar information here, but this is broken down by the team itself, as well as the drivers that were on that team for those years. Again, slicing information is all live. If you click anywhere in here, for example, if we click on Haas, you'll be able to see here are all of our information year over year by driver. This is again where we mentioned the turnover year over year between our drivers and the tiny slice of the pie that they have thus far. This is what we want to change. Now we're going to demonstrate for you the mobile Power BI application as well as our own custom Formula One mobile application. Click on the Power BI icon, takes us into our dashboard here. You'll notice that the dashboard is the same as the dashboard that you saw in the full web experience. We've got our circuit information at the top, constructors in the middle, and drivers at the bottom. All of these visualizations are live. For example, if I click on the map, it takes me in, and you can see all of our circles based on the data size, as well as the individual pins. If I zoom in, all of that information stays relatively the same, so I can see it shift as I move around in the map. If I go back to the home screen and I click on the constructor's pie chart, this now becomes a live pie chart that I can click into, and the information at the top of the screen changes. For example, if I keep clicking, here comes Haas right there. If I go back, drivers the same way. It's a live updating pie chart, which is pretty neat. In addition, if I wanted more information, I could click on this ellipses down here and go to the actual report. What that will do is it'll actually take me to a full mobile version rendered of the web application. So basically, I could have the same filtering, slicing, and dicing as I do on the web, but right here on my mobile device, which is pretty neat. If I go back to the home page here, you'll notice that the icon that we have for our custom Formula One application is a key. We believe that this might be our key to success. We click into the application here. Boom, you'll see how quickly that renders. You'll notice it's the same dashboard that you saw in the mobile Power BI dashboard. However, this one is totally customized to us. We're still developing the backend to see what else we want to add to this, but it's pretty neat that we have our very own custom application. And with that, I'm going to pass it over to Tiffany to talk about SAS modeling.
Okay, so now I'm just going to do a quick walkthrough just to give you an idea how Enterprise Miner made modeling easy for the Formula One team. This is our early example of what was done. Basically, Enterprise Miner is very visual. All you need to do is basically connect your data source, which we've done here. This is our data set. There's a lot of different options for manipulating that. I'm not going to cover that here. But I do want to show you the data exploration feature, because this is by far one of the most powerful tools in terms of getting us up to speed quickly to find insights and move the project forward. So we're going to start by editing our variables. And this is basically all the variables available in the data set. I'm just going to, if I want to take a look at these, now this is also pretty interesting. We can go and change what role and tell it, like, is this a target variable? Is this a variable that we want to look at as an input? You can actually go through here and actually tell the tool which ones you want to use and which ones you maybe even don't want to use. which is fairly nice. In this case, all we're going to do now is just do a quick exploration because we just want to see what we got here. So we're going to select all these real quick, hit explore, and see what we get. That's okay. So here's what we have. Basically, Enterprise Miner allows you to grab multiple data sets and see, we can do a quick visualization. This does a quick count of how many rows, how many columns, and this just gives you an idea, a quick look at some of the top observations, okay? Outside of that, what's really fascinating here is, let's say I want to know for qualifying, for example, any of these here, I want to get an idea of those that make it to Q3, how do they relate to the other data that we see here? Well, all you need to do is simply select one of the items that you care to find a relation about, and it'll tell you, well, in this case, Q3 is directly related to the results in Q1 and Q2, which makes sense, and also potentially how people perform in all these different laps around the circuit. So that's pretty neat. So this is kind of one of the great powerful features that Enterprise Miner has, is it allows you to quickly and easily see insights. Okay, now that we've had a pretty good look at the data and we're able to find some pretty interesting insights right out the gate using the data exploration feature, we also notice that we have quite a few missing variables in some of these, or missing data sets in some of the variables. In order to address that quickly and easily, SAS has made it pretty easy by creating an imputation node. And in that node exists all the known ways in which statisticians and data scientists impute data. And what SAS has done pretty smartly is they will go ahead based on the variables and pick the best solution for imputation. Now you can go in, and which we did, and change which type of imputation that you like. For example, you may take the average of a number. In our case, we tried the max on some of the lap times. So we maxed out, we basically put the max. And then we decided, no, we'll just leave it with the mean. So anyways, this gives us the flexibility to kind of play around and see what makes the most sense based on the type of variables. And the imputation rules were done quite quickly. The next step here was, from imputation, we realized as we explored our data further that we may want to take a look directly at Haas and also the top two teams, Mercedes and Ferrari, independently in the model. So we created a flag variable using the SAS code module. It was quick, pretty easy. You pull it down on the canvas, you open up the editor, and you basically put a few lines of macro code which set the flag variable for the instructor ID of Ferrari, Haas, and Mercedes, which we did. This allowed us to do some further analysis on the data. Okay, now on to the fun part, modeling. SAS makes this incredibly easy. So we did quite a few different modeling attempts with SAS. We started with all the data. We ran some initial models. We got some great insights, such as the results grid position, the status ID, and these began to dominate the model. It was quite clear that each driver would really need to finish the race in order to get points. I think, and actually some of that is kind of well known within Formula One. The other is the position in which you end up at the end of the race. Clearly, although that was interesting in the data set, it really isn't interesting for modeling. It says, well, guy got 1, 2, 3, or 20. So if he gets 1 through 3, obviously he does well. So the results position and the status ID dominated the model as the biggest predictors, and that makes sense. So those kinds of things we pulled out because they're kind of stating the obvious, and we tried to peel back the onion of it to see what other factors could be driving points. Once we took out some of the obvious things such as result position and status ID, and not to mention we got some good insights that we could share with Haas in terms of where the big teams are falling on some of these, and that was important for us to also identify. But I think what the interesting part was when we peeled back the layer, we saw something different. We saw the driver ID pop up as by far the most dominant predictor. Once we saw that, we started to get some really great insights. If we talk about the modeling, let's talk about the process. The process we did here in SAS was we started with just pulling down the 3 top models, running the compare mode node, which is really fantastic. So what this does is it automatically selects based on the key KPIs for statistical modeling, and it tells you basically which one had the best fit and which one performed overall the best with the least amount of error. And it'll tell you that score automatically to put a Y next to it. So we ran that, we got some great results. And then what we decided is, you know what, we need to actually start with variable selection. Our wonderful SAS consultant gave us that advice is, hey, why don't you try this? So we put the decision tree actually in front of the other 2 models, the regression model and the neural network. And then we ran it again, letting the decision tree select the variables for us in advance of modeling. We also tried the variable transformation. We tried that, it worked okay, but the decision tree by far was the most efficient in terms of selecting the variables. It turns out in the end, the final model, it was also the best model. And we'll see further on how the decision tree in general tells the story in a more visual and relevant way to the types of data analysis that we're trying to do for Formula One. But again, SAS Enterprise Miner made this process very easy. We'll continue to iterate. We're also going to build a scoring program. If you look at the visualization again, our graph, we've already created an initial scoring program to score our final model, which was a decision tree. And that again, that's where we're going to head to as we continue to work with the model. Now that we've selected our decision tree model, we still need to validate it. To do that, we look at our decision tree statistics. The main KPI for decision tree is a variable of importance. In our case, the primary variable of importance in our final model is a driver ID. Both the training and validation data are 1-to-1, which is basically perfect, meaning that it's 100% predictable that the driver will drive points. The other variables, as you look down the model, are also quite important, but not nearly as influential as important as the driver ID. But we still need to evaluate their importance. To do that very quickly and visually, you can pull up the tree and you can look at the model results. And what's really great about Enterprise Miner is that you can click on basically anywhere in the tree, and it'll drive a graph below. In that graph, it'll show you for that leaf that you picked, it'll show you all the nodes within the leaf, and it'll give you a side-by-side of both the training and validation data. If there's major variations in either, then that data should be ignored. In our case, we had about 3 areas on the node that I selected that we need to ignore. The main reason was the number of the data set was very small, which means the data is not very predictable. So we want to follow where the bulk of the data went. And that's what's great about a tree. You can follow the tree down for where the results make the most sense. And this is how we validate it. Okay, now we're to the fun part, reading the results of the decision tree. I'm going to show you first the first run of the decision tree, where we identified 4 key variables in which we recommend to the Haas team to make a sort of standard goal for each race. The left side of the tree shows where the top 3 teams tend to lie in terms of the qualifying position, the status ID, qualifying number, and the results grid. These 4 variables are the key to making sure that you earn the highest points during a race. Obviously, if you score anywhere between 1 and 3, you're going to be on the left-hand side and score the highest possible points. If you score greater than 6.5 or less than 6.5, you can have a higher potential for scoring points. But what's great about this tree is it gives you a great guide to where you do and do not want to be in terms of points. If you follow the far left of the grid of the tree, you'll see that this is where you score the least amount of points if you don't pass these key areas, such as earning anything less than 6.5 on the results grid and so forth, because Formula One does not award points past the 10th place. So this is a great guide, but it doesn't really give us any impactful insights, as these are very well-known factors within Formula One.
Thanks, Tiffany. We were able to extract a tremendous amount of valuable insights through our analysis in Power BI and SAS Enterprise Miner. However, we wanted to take it one step further and test the statistical computing power of R to see if we could find any additional insights. Unlike our modeling in SAS Enterprise Miner, where we used results points as our dependent variable, in R we chose a different approach and created a new variable that indicated whether or not a driver finished in scoring position, that is, places 1 through 10. By doing so, our model provided insights into the ability to score points rather than the number of points being scored. Once we had created our new variable, we divided our dataset into subsets for each of the 10 current constructors in Formula One racing. We then analyzed their Pearson correlation coefficients in order to determine what factors had the most effect on all constructors, some constructors, and especially on Haas individually. Taking a closer look at the Pearson correlation coefficients for Haas, we found several negative correlations and much fewer positive correlations. Overall, Haas had the most number of strongly correlated variables of all the constructors. This may be due to Haas's infancy in the sport, as they try to find what works for them. In an attempt to find more valuable insights, we investigated the positive correlations that were unique to Haas, one of which was weather pressure, the measurement of atmospheric pressure in inches from our weather data. There are two major ways in which atmospheric pressure can affect a race. First, by increasing the downforce on a vehicle, which leads to better grip and handling, but also increases drag. Second, a decrease in atmospheric pressure can lead to a decrease in engine power, as the air molecules start to become less dense. This also leads to a decrease in the combustion burn rate and an increase in fuel evaporation. We want to dive into our findings even further by calculating the effects of atmospheric pressure on all constructors. The average atmospheric pressure for all races in our dataset was 29.98, with a very limited range of just 29.54 to 30.37. We broke down the data into subsets for races with an atmospheric pressure above and below 30. We then computed the number of times scored, the number of points scored, and averages for each constructor for both subsets. The majority of constructors saw minimal changes to their scoring ability based on atmospheric pressure, with the average constructor scoring just 3% more of the time and 5% more points in races above 30. However, when we looked at Haas's numbers, we found something that was very exciting. Haas scored in twice as many races when the pressure was above 30, and scored nearly 45% more points during those races. I'll say that again. In races where the pressure was above 30, Haas scored twice as many times, and nearly 45% more points during those races than in races where the pressure was below 30. Now let's bring our team lead back up here to summarize our analysis and discoveries. Take it away, Joey.
Thanks, Ryan. We began our project with the hypothesis that simply finishing races would allow second-tier teams to maximize their points. Based on our analysis, our findings support that belief. In addition, we believe that if we can make atmospheric pressure adjustments on the race course, find a better second driver, and focus on the finishing rather than attempting to win, Formula One points for Haas can be maximized. This will translate directly into additional revenue from the Formula One organization. In addition, an improvement in points would increase their sponsor revenue and improve their driver recruiting opportunities. More about this will come in the recommendation section further in the presentation. Our analysis has shown us that the constructor, team, driver, status, and qualifying position are all key predictors of racing success. We've also seen that some constructors are much more successful at improving their finish from a weaker qualifying position. On a more minor note, we observed that quick times on specific laps can be factors in success. These laps may be at pivotal junctures in the race, or it may indicate that the driver and car have survived late in the race and thus are likely to finish that race. Going back again to the key of finishing races as opposed to simply winning races. One of the most striking pieces of analysis is that our project was able to identify a clear relationship between atmospheric pressure and performance. Moreover, Haas's specific performance in this area differs from all other constructors. It's actually much, much worse than the rest of the teams that we were able to analyze. In addition, there's a clear relationship between the driver and points. When we modeled out this relationship further, we were able to determine that the driver should be another area where Haas should focus their attention. Again, more on this in the recommendations section later. And while this may seem like an obvious analysis or an obvious statement to make, it was really proven out via data, and thus it's much more justified.
And with that, I'm going to pass it over to Tiffany to talk about recommendations.
Okay, now we're on to our final model, the final model tree. And we already talked about how we qualified some of the data, especially on the left-hand side, where we really want to focus. Let's start with the right-hand side. Here is where the majority of the field does end up, majority of the drivers in this case. And as we've mentioned before, driver ID is the most predictable factor. Looking at that, we see the main group of drivers splits into two primary groups when we go all the way down to the bottom of the tree. And in this case, you follow the tree to the left-hand side for maximum points until we get to the bottom. And this is where it diverges slightly. And on that divergence, we see both of our Haas drivers. On the left side, we have Kevin Magnussen. On the right side, we have Romain Grosjean. And it shows here that he can get a maximum points of about 5.3. If he follows, if he gets through lap 11, lap 43, and he gets a decent qualifying score. So if he does all these things, that's the maximum points within a race that he's capable of achieving. And on the left-hand side is our other driver for Haas, and his points are quite a bit lower. So combined, they're about 8th place. And actually, if they do very well and they make it through all these, the qualifying Q2, lap 11, lap 43, they can actually move themselves up potentially to 5th place if they can continually score a combined total of 8.3 points per race. And what's great about that is that at the end of the season, if they could do this every race, they could actually increase the revenue for Haas by $19 million. Now let's look at the other side, the left-hand side. Although we mostly wanted to ignore that because this is where the top teams perform, we really want to focus on the bottom. We actually found some interesting insights. The main insight here was looking at the top 10 drivers. Of the top 10 drivers, they branched out into two distinct groups, one on the left, one on the right. The one on the right-hand side was probably the most interesting because one driver in particular stood out. His name's Robert Kubica. Robert Kubica is an active driver, but he is not driving for a team. He is a backup driver for the Williams team. The reason he's a backup driver is he had an accident off-season in 2011, and he's trying to make a comeback into Formula One. But the model doesn't know that. The model shows the results, and the results show that this driver is a top contender for the top drivers in Formula One. That's an important fact. He's very knowledgeable, he's been around, and he can perform. He's one of the fastest drivers in Formula One, quoted by Nico Rosberg, who is the 2016 champion. And more importantly, Nico Rosberg, who is on this tree as well, on the left-hand side, is a world champion 2016 and is an equal to Lewis Hamilton, the #1 driver. And Nico has said the two fastest drivers in Formula One he's ever raced against were Lewis Hamilton and Robert Kubica. And as a result, he has now become Robert's, because he has retired from Formula One, personal manager, which is a pretty exciting thing. Our recommendation in our team here is if any way Haas could get Robert to drive as a primary driver on the Formula One team, if you combine him with Roman Grosjean, you have nearly 14 points, 13.94 points that they could score in every race. Given the factors that they can get a good qualifying score, get past lap 43, do well with lap 11, these guys can do really well. The net is 297 points in the season, and now Haas could potentially move from position 8, where they are now in the Constructors' Championship, to position 3. And that actually nets the team more than $22 million. So this addition to the Haas team is a potential recommendation that we make. Of course, like any driver, because he has been in an accident, he should be tested to ensure that, that there aren't any physical issues. His tests so far in Williams look very promising that he has what it takes to come back to Formula One.
Thank you, Tiffany. We found in our analysis that atmospheric pressure has considerable influence on Haas's scoring ability. An increase in atmospheric pressure will increase the downforce on a vehicle, giving the driver better control. However, that difference would be shared across all constructors. The effect on Haas is more likely due to engine performance. We see two possible options for Haas. Either make adjustments to minimize the effects of atmospheric pressure on the engines in our vehicles, or take advantage of our scoring ability in races where the pressure is above 30. In order to implement the proper engine adjustments, we would need to involve R&D and allow them to research other constructors and see how they cope with lower atmospheric pressure. Then we could devise a plan that would minimize the effects that pressure had on our engines, or at least allow us to make adjustments during races where the pressure is below 30. Alternatively, we could take advantage of our scoring ability in races where there is high atmospheric pressure. We could do this by utilizing a more aggressive racing strategy during those races, employing a higher octane fuel for the season, and or minimizing the number of pit stops executed. Any of these approaches should increase the number of times our drivers finish in scoring position, thus increasing our total number of constructor points and increasing our revenue. With that, I'd like to turn things back over to Sergio.
To test the merit of our findings, we reached out to Giacomo Ricci, Kubica's team manager, regarding a possible interview. We would like to discuss the feasibility of Kubica's comeback as a lead driver. This week we had an email exchange with Ricci. After Ricci pressed for a more in-depth explanation of our intent, communication paused. We can't help but wonder if Ricci fears we are trying to recruit Kubica. Needless to say, we'll continue to pursue this angle. About that Russian meddling in Formula One mentioned at the beginning of our presentation. Just this past January, Russian Sergei Sirotkin was selected to drive in Formula One over Kubica for Team Williams. Many reputable sources believe that the decision was driven by large dollar sponsors controlled or strongly influenced by none other than Vladimir Putin. Why do we care? This leaves Kubica on the market looking for a job at a very reasonable price. This could be a gain for Haas based on our analysis. Is there a future engagement opportunity here? We believe so. Based on comments from Daniel Knost of Haas during our interview, analytics may provide a means to optimize the large factors of every race, those being driver, car, crew chief, and pit boss. During our project, we did not have time or resources to consider this problem. This might be an opportunity for future students so long as they can gain access to the data. Hold the presses. Late-breaking news. Just as we were about to publish our final recording of this presentation, bam! We have a job offer, or at least an offer for additional work. Our teammate Tiffany discussed our project with the president of a racing club in Palo Alto. He was so intrigued that he asked us to do some work with his data, and Wait for it. There appears to be cash connected to the offer. We are very excited. Okay, back to the flow of the presentation. Of course, we have had fun with this project, but let's get serious as we wrap up. By implementing the recommended strategies, Haas Formula One will increase revenue. Each of these recommendations tie to a key factor for growing points and thus growing revenue. This is similar to the getting on base concept in Moneyball. Finally, given our significant finding on atmospheric pressure relative to performance, we will share our final report with Haas. Competing on analytics. It is an overused phrase and has become almost cliche. However, we have found through analytics several opportunities for Haas to become more competitive. We are very excited about the atmospheric pressure findings as well as the driver selection insights. We are confident in our work given our post-interview communication with Daniel Knost of Haas Racing regarding our initial findings. As he put it, our work is on the right track. We'll close out with a quote from ComputerWeekly.com from the Formula One leader Mercedes. With such small margins at stake, racing teams need to wring every ounce of performance from the car, and that means harvesting and analyzing as much data as possible from each race. The Mercedes team is doing just that with a project that promises to turn data into wins. Mercedes, with its massive resources, is racing to win every race. The opportunity for Haas is not winning, but racing to maximize Formula One points in every race and thus maximize revenue. We have shown for Haas, this is a project that promises to turn data into revenue. Thank you for your time. We look forward to your questions and the opportunity for future work.